Good evening, ladies and gentlemen, boys and girls, children of all ages. My name is Alistair Hobday. I'm a Research Director at CSIRO in Hobart, and I'm your chair for tonight's event, a very special event titled Climate Change Matters, the Australian Context. And we're bringing this to you on only the second day after the report that we're going to discuss was released yesterday. I'm bringing this event to you from the land of the Muwinina people, and I pay my respects to their elders past, present and emerging, and note that they are the traditional custodians of the land on which we're meeting today. We are still living in another kind of extreme event, and it's the COVID pandemic. Please keep your distance from one another, particularly if you don't know them intimately. I'm hoping that the couples here tonight all know each other well. Groups of 3 will discuss later your particular arrangements. But please keep your distance from one another, use your masks when you can, and if you're at the podium speakers, I'll give you the, please take your mask off for clarity of presentation tonight, and then we'll wear them again at the seating arrangement over here. This is a simulcast event. We have an online audience in Hobart in front of me, as well as people joining online. I invite you to use either the Zoom chat if you're online, or if you're in the audience or at home tonight, please use the application called Slido. You enter sli.do into your mobile device, and then that has the opportunity for you to punch in questions at any time during the meeting, and then we will bring those up at the end of the session and have some discussion about those particular questions. I'll leave that up for just a sec before inviting Rufus Black to the podium here, but just we're hearing about something that's a real global challenge tonight, and that's climate change. I'm very mindful that it's taking place tonight at a time of great turmoil around the world. In Queensland and New South Wales, people are living through their own extreme event right now. It was a similar situation with bushfires in the Australian summer more recently, and Tasmania again has had its own experience with floods and bushfires. They're natural extreme events that cause great social disruption. Another social disruption is happening in Europe right now with the Russia-Ukraine conflict. And I know that people in Tasmania will join me in feeling great concern for the outcome of that situation and hoping that no lives are lost anymore and we just sort things out there. With the threat of climate change in front of us, we need all our energy on the natural world, and to create conflict, outside that is really frustrating and saddening that people are still dealing with conflict there in the Ukraine as well in other places around the world. The people who work on climate change are doing it because they care about the planet. And while the focus here is on perhaps the physical, the biological and the human environment, we're all doing that work because we want better outcomes for society and a safe world for our descendants to work in and live in and enjoy as we do tonight. So I know that is a sombre message, but it's the reality at the moment of what is happening around the planet, and sometimes it gets you down. Professor Rufus Black is the Vice-Chancellor of the University of Tasmania, and Rufus, I'll invite you to the stage now for some welcoming remarks.
Thank you, Alistair. Mina Tanapri, Muwinina, Nipaluna, Latruita, Milaidina Pakanatu. I acknowledge with deep respect the Muwinina people of Nipaluna, country of Hobart, Latruita, Tasmania, Aboriginal land. In acknowledging country, I want to also acknowledge an observation our colleague Greg Lehman makes, which is to note that the Aboriginal peoples of this island over their 40,000 plus year history have navigated climate change on this island and done that successfully without seeing ecological collapse or indeed creating empires or the kind of wars that we see. But he would also observe that they were only able to do that because the rate of change was actually possible for adaptation to occur. And tonight we gather at a point where the world faces a choice about whether the world can actually proceed at a rate of adaptation that a human society can meet or not. And so it's a real pleasure to welcome you here to the University of Tasmania for what I think is an enormous privilege to hear from people, authors and intimately associated with this work when it is so fresh and so pressing. As a university, we are deeply committed to a broad sustainability agenda and, of course, to putting all of our institutional effort into tackling the challenges of climate change. When you read this report, and I've only had the privilege of reading the summary for policymakers today, it is a report that, for me, stands me between two feelings of despair and hope. The report contains kind of a compelling confrontation with some of the most challenging facts that human civilization has probably had to deal with a genuine confrontation with our absolute need for action and our willingness to point the finger firmly at those who need to take action. This is a morally compelling, not just a scientifically compelling document. But it's also one that, if you read it in the light of the history we've had of gross global inaction on these issues, could easily lead you to despair, to a sense that the pathways to a less attractive future that it charts may be the pathways we go down. And I feel with vigour in a university the kind of concern and outrage of young people who live at a time where they have seen us go down a path, those of us who have any influence, into a world which, if it continues on that path, will leave them and their children with a very, very unattractive future, not of their own making. They understand the urgency of this, and there is a power in their voices which we need to hear on a night like tonight. It is a compelling voice for action. And that's, I think, where the other point of hope sits when I read this, because it isn't just a document that charts the disasters that happen down one path, it's also a document that charts a pathway to hope, a scientific, evidence-based set of directions about how we can chart our way to a very different kind of future to the one that we've been on. And to have hard science backing good policy like directions like this is a powerful source for hope. And also with a sense that there is a window of time that will enable us to act. It is not too late. The clock has not hit midnight, and this report makes that clear. But as the report describes, that window is closing. And so it is of compelling importance that we attend to it, to its contents, and to the deep experts that have shaped, created, and authored this, and it's a privilege to have them here tonight. But I should also say, as we look around the world with the causes, plenty of other causes for despair, and Alistair mentioned some of them, and our feelings are certainly there with anyone associated with the Ukraine, or anyone caught up in that world, or in any of the other numbers of conflicts that we have around the world that get less headlines. The one thing about Ukraine that maybe is a little spark for hope is it has reminded the world that the only way in which we tackle conflict is with collective, ethically grounded action. That the only way that the world can tackle its common challenges is with common action and with levels of resolve that bring nations together against the big challenges that face them and enable them to take actions that in the short term might seem lacking that run against their own interests, because there is a greater common good that has to be achieved. And there have been, I think, the reawakening of that glimmer of hope in the European situation that it is possible to cooperate to deal with conflict. We now need the world to find the same level of resolve to cooperate when it comes to climate, to recognise that it is only by unified global action against a truly scientific agenda that this is possible. And that's where I think a night like tonight, and I welcome all the colleagues joining us online, is important, because in the end of the day, in democracies like ours, it is the capacity to respond to a sense of what ultimately people are calling for, and particularly when we have the opportunity to do it on such a deep evidence base. So I welcome you here tonight, and to the colleagues who join us. I suppose I couldn't also come here tonight without a tinge of sadness, and a lot more than a tinge really. When we last gathered as a university talking about these things, Dr. Rebecca Harris was with us and made her ever vital contribution to that discussion. and her death this past summer was a great loss to our community here and to the wider scientific world. And I want to acknowledge her presence tonight in the work that is before us. Her loss is very much still with everyone who knew her, whether it was closely or distantly. Her contribution was huge. So tonight, I welcome you warmly to what I think is a vital conversation and the privilege of hearing people so closely associated with this work provide their perspectives on it. Thank you and welcome.
We are really fortunate in Tasmania to have so many excellent researchers working on climate change. Tonight's event was coordinated by the Centre for Marine Socioecology, which involves many of these researchers working together to actually do the socio-economic aspects of climate change. In a way, over my 20 years in climate research, it's really nice now to be able to say, I don't need to go and do more work to discover impacts. My own work and that of the people you hear from tonight has largely moved through to what can we do about it and how can we help society adapt. We don't need to ask for more money for government to go away and research impacts or discover what might have happened in the past. We're on a body of knowledge now that's just an incredible resource for making these future decisions. And I'm really pleased to be able to introduce the speakers to you tonight, which will take their turn to tell you about their perspectives of the IPCC process and report. May I ask those panellists to come and sit with me in front as I introduce them. And first up will be Professor Gretta Pecl. She's the Director of the Centre for Marine Socioecology and one of the lead contributors to Australia's chapter that's in the IPCC report. Professor Neil Holbrook, also joining us here, is a Professor for Ocean and Climate Dynamics and Head of the Centre for Oceans and Cryosphere at IMAS. Jess Melbourne-Thomas is a researcher and senior scientist at CSIRO, where she leads a team on marine socio-ecological studies. And she was a contributor to an IPCC report last year, on 2019, that was on the oceans and cryosphere and a changing climate. Professor Phil Boyd works on marine biogeochemistry at IMAS, and he was a lead author on the Chapter 3 for ocean systems. Professor Boyd. And Andrew Constable, associate researcher at the Centre for Marine Socioecology, very long history in ecosystem-based management and developing solutions, particularly around Antarctic science, conservation, and how we manage humans in natural systems. Gretta is the first of the speakers tonight. May I ask you to join me at the podium and I will go the other direction.
Great.
Thank you.
Thank you very much, Alastair. So tonight is all about disseminating the findings of the IPCC report, and the IPCC can be a bit of a mysterious beast. And I recall a few years back when, even though a lot of my work ended up being cited in the IPCC, I still really didn't have a very good understanding of how it worked, what it was, and I thought if I, as a climate scientist, find this quite mysterious and confusing, then a lot of other people must also find that a bit of a mystery. And so I thought we'd start off tonight with just a very quick description of what is the IPCC and how does it work. So the IPCC, or that Intergovernmental Panel on Climate Change, is an international body that represents 195 countries around the world, and it produces global assessments reporting on climate change. And these reports bring together all the recent information and the technical literature, the scientific literature on climate change. And it is intended to be policy relevant, but not policy prescriptive. So it's not our job to say which policy A or B is what should happen. So there's been 5 comprehensive reports of the Intergovernmental Panel on Climate Change since 1988, and 3 special reports. So there's been the Global Warming of 1.5 report, trying to establish what the planet would look like if we could limit warming to 1.5, a Climate Change in Land report, and the Ocean and Cryosphere in a Changing Climate report. The sixth assessment, this report that we're talking about now, has been a little delayed by COVID, but this is the sixth assessment report to occur, and it's composed of separate parts. So there's a report that came out a few months ago on the physical basis of climate change, Working Group 1. Then there was this report that we're talking about tonight, is the report concerned with impacts, adaptation and vulnerability. In a few months, there'll be another part of this assessment around the mitigation of climate change, and then a few months after that, there's a gigantic synthesis report. So when people talk about the IPC assessment, there's multiple components and parts of that, and I think that's part of the reason why it can be a little confusing, because we talk about, you know, this is the first assessment since 2014, but there have been other parts and other components between now and then. So the IPCC is made up of, for this assessment report, around 700 lead authors and review editors from about 90 countries. So the IPCC represents 195 countries, but the contributing authors are from around 90 countries in the world. We all have to sign conflict of interest statements declaring where we get funding and research support from. If we have any conflicts of interest, we have to update that every year. So it's quite a strict policy for us as authors to declare any conflicting interests that we have. This sixth assessment report that we're talking about now, the two parts that are out already, that physical basis, that had 234 authors in it, and those authors addressed over 78,000 review comments from other scientists and experts and government reviewers around the world. So when you see those YouTube videos saying, what about this and what about that, that has all been considered multiple times over by many, many thousands of review comments. And when we get those reviewer comments, we have to answer each and every one of those in detail in an Excel spreadsheet, and that's checked by multiple different review editors to make sure that we have actually considered that comment and we have actually made that response. So you can imagine an Excel file with 78,000 separate comments in it about particular parts of these reports. And this physical science basis report cited and assessed over 14,000 separate scientific studies from around the world. The second report there, the Impacts and Adaptation and Vulnerability one that was released last night at about 10 o'clock and that we're presenting to you tonight, that had 270 lead authors from around the world and addressed over 62,000 review comments from scientists, government representatives and anybody that wants to register as an expert reviewer. And we assessed over 34,000 separate studies. So when what we're presenting tonight seems like these high-level statements, but there is an incredible amount of information and literature and evidence behind each and every one of the statements in these reports. The assessment report 6 structure starts off looking at risks, adaptation and sustainability for different systems. It looks at terrestrial, oceans, water, food and fibre, cities, health and wellbeing and poverty, livelihoods and sustainable development. So that's a section all about risks, adaptation and sustainability. Then there's the regional sections, a chapter on Africa, one on Asia. The chapter that we'll present, most of the information we present to you tonight will draw from the Australasian chapter. Then there's a section on sustainable development pathways, and that's something that Andrew will speak to later. Then there's also a whole lot of cross-chapter boxes and cross-chapter papers on particular issues. So Indigenous peoples was one of those, polar regions was another. So there's particular issues that are picked up in other sections as well. But tonight we're talking mostly about the Australasian chapter. One thing I want to say is that the language that we use in IPCC is incredibly calibrated. We can't use words like may, will, likely, possible, all those kinds of things without there being particular types and quantity of evidence behind those statements. So where we say very high confidence or medium confidence or low agreement, terms like that, each one of those has a really specific meaning, and we have to go through each and every one of those statements and scrutinise the evidence and record the evidence that allows us to make that kind of assessment. So what I'm trying to communicate to you is that it's an incredibly robust, detailed assessment of extraordinary breadth and depth. There really hasn't been other types of assessments of planetary processes and situations as the kind of thing that the IPCC does. Over time, with the IPCC assessments that have come out, they started in 1990, giving a broad overview of climate change science and discussing the uncertainties. 1995 said the balance of evidence suggests a discernible influence on the climate. 2001, there's new and stronger evidence that most of the warming is attributable to human activities. 2007, warming of the climate system is unequivocal. And then 2013, human influence on the climate system is clear. So I'm trying to show you the progression over time there of these assessments and how they've arrived at more and more certainty around what we're presenting. And you'll see a step up from that language in what's been presented in these reports tonight. Some of this, as Rufus and Alastair suggested, can be quite overwhelming, and it can be easy to feel a sense of doom and gloom. But I think it's important to acknowledge that in addition to pushing for systemic change, there are other things that we can do, and it feels better to be doing something constructive about these problems. So we can be reducing our own footprint or talking about climate change. We can be participating in citizen science and helping contribute to the knowledge and the information that we have about the world around us and how that's changing. And we can ask questions and get answers from reputable sources. But it's important not to give up. And the primary reason for that is every fraction of a degree of warming that we avoid improves the outcome. So as you're being presented with some of this not overly positive information tonight, keep that in mind. Every fraction of a degree of warming that we can avoid really does lead to a better outcome for us, for our descendants as well. Thanks very much.
Thanks very much, Gretta. Okay, my name's Neil Holbrook, and I'll be talking about the physical science basis, which is the first report of the AR6, or the sixth assessment report that was released in August last year, on the 9th of August. I'm not an IPCC author, but I have been working in oceans and climate for the last 30 years. So I'm grateful to be able to just hopefully give a perspective or a balanced view of how the report is actually presented, and just present those key findings and represent those hopefully faithfully. And this really starts out with these first, I guess, these key findings, these 5 key findings, just reflecting back on the fact that this report, as Gretta said, was authored by 234 authors. It turns out across about 66 countries, I think it was, and 14,000 peer-reviewed publications were considered through that report. These reports come out only so often, every 6 years or so. And the culmination of this particular report in the physical science basis, which is this first report that came out some months ago, I guess the first statement is really the climate system is warming, and there's probably no surprise there, okay? So we've known that for a long time, and we've seen that through previous reports. But this next statement is pretty profound, okay? Warming is unequivocally caused by human activities. So you saw the statements that came before it in the previous reports. So if there was any doubt that humans weren't the cause of this, there's no doubt anymore, okay? So this is a responsibility that's incumbent on us, and we need to take responsibility for our planet, and we need to do something about it. This is a very strong statement by IPCC. Human-induced warming has caused an increased frequency and intensity of climate extremes. I'll talk about that a little bit later. Future warming will depend on the effectiveness of emissions reduction. So I've got a couple of slides that talks about the emission scenarios that are played out going forward and what those look like in terms of carbon emissions. And warming will become increasingly dangerous for human and ecological systems. And I think that's really going to be borne out by the presentations this evening on the Working Group 2 report that the other people here in the room are going to be talking about. But hopefully this just sets the scene from the science basis. They're very high-level statements and just sets the scene for what's going to follow. And the key point here is concerted aggressive action can reduce climate impacts and help avert catastrophe. It's not too late, as Rufus said, but it is going to require an incredible international will and effort and people on the ground to do things in a positive way. So, firstly, Earth's climate is warming at an unprecedented rate. So this figure here really shows how temperatures have changed over the last 2,000 years. You can see that this is really stretched out here over the last 2,000 years, but in this very last bit here from 1850 to 2020, you can see that there's this sharp rise. We've seen these types of figures before. It's presented again here. We're now at 1.1 degrees above pre-industrial levels, and for those pre-industrial levels are sort of between 1760 and 1840. Okay, so things going forward we tend to think of from 1850 onwards. It's basically unprecedented in the rate of warming over the last 2,000 years, and you can see that. But it's also warmer than any time in the last 100,000 years, and you can see this bar here. This represents about 6,500 years ago during this particular interglacial now, when it was reasonably warm, but even that, it's above that in this last 100,000 years. This next statement around Earth's warming is caused by human influence, and this is really borne out, I guess, reflected by the way that we try to model our climate. There's multiple lines of evidence to try and understand climate change, from observations and so forth. Models give us an understanding of the physical basis for things that we see. It gives us an underpinning. They're very sophisticated tools. They're three-dimensional in space and time. They run forward, and you can see here these brown lines and green lines are reflective of a suite of models called the Coupled Model Intercomparison Project models, CMIP, sixth phase, running particular scenarios where looking at only natural forcings, solar and volcanic, versus natural forcings, including as well as human activity. This black trace here shows the observational record as the average temperatures annually over time through since industrialisation, since 1850, and you can see that there's variability there in time. But the only way that these models can capture these trends since we've added CO2 and other greenhouse gases into the atmosphere is by following the simulations of human and natural. And hence that particular point is really key to this IPCC statement that it is unequivocal that human influence has warmed the atmosphere, ocean and land. It's faithful to the representation of the climate of the planet. It understands the sensitivity and it represents that physically. Now, this figure is a little bit complicated, so I'm just going to take a little bit of time to explain it. But really what it really shows is the relationship between temperature up this axis here in the vertical axis, which is linearly related to the cumulative carbon dioxide emissions since 1850 across this axis. So you can see those are increasing there through the observational period, since observations way back, the observation timeline is down here, but this is basically increasing through the observational period here with this black trace. By increasing CO2 emissions, we've increased the temperature to our 1.1 degree here. And then there's these scenarios going forward, and I'm just going to spend a little bit of time talking about those here. And they're represented in the Sixth Assessment Report as shared socio-economic pathways, or SSPs. Okay, previously they were represented a little bit differently, but basically they're a collection of scenarios that were put together by climate scientists, economists and energy scientists that explain potential pathways based on our energy use going forward and our energy emissions. So you can see here from more sustainable paths, this blue one, SSP1, so that's like a much more renewable type of lifestyle and carbon emissions going forward, through to this fossil fuel development, this SSP5, which is a very intensive one. There's a middle of the road SSP2, okay, and I'll talk a bit about that later, and this SSP3, which is like low international priority for environmental concerns. But this figure here shows the amount of cumulative CO2 emissions through to 2050 of each of those. So in other words, the total load of carbon dioxide emissions that would be under those scenarios. So that actually goes through to 2050. So even though it sort of suggests here that it's only 2030, it's basically, you can drag it down here to 2050, and that's the total load that it's going to be. So it's around about 3,000 overall since the beginning there, and we'd expect a warming there of around about just on 1.5 degrees or a bit lower. And then you can see as you go forward, 2.6, then the 3, and then the SSP5, we're really getting up to around 4,500 gigatons of CO2 and a sort of let's say an average temperature rise. This is by 2050 only, not by 2100, which I'll talk about in a moment, of 2 degrees. So the key here is that in terms of the cumulative CO2 emissions, linearly you can see this graph across here in terms of gigatons of carbon or billion tons of carbon dioxide. But in terms of the emissions pathway since 1850, you can see that those numbers are actually stretched out here, and those emissions have actually accelerated dramatically through the lifetime. So you just got to kind of look at that for a while, and you can imagine how these emissions are actually really accelerating as we go forward under those different scenarios and the damage that potentially do. So here's pictures now of a picture now that shows the observational period and then these particular trajectories then through to 2100. And this is really now talking to the whole underpinning of the Paris Agreement that was released in 2015, aimed to limit warming to well below 2 degrees and preferably be below 1.5 degrees. You can see here that the more sustainable pathway goes up a bit going forward, and it actually goes past about 1.5 degrees by about 2030, but then it comes back. This is the kind of trajectory that we really want to go on, okay? At least this. This is something that we should be aiming for, striving for, at least going forward. At the other end of the spectrum, we don't even want to imagine. SSP5, fossil fuel development out to potentially close to 5 degrees warming by the end of the 21st century. Okay, that would likely have catastrophic consequences, and I'm sure the team will talk about that later. Even the middle of the road trajectory, which is sort of like doing similar to what we're doing now, will take us beyond the Paris Agreement of about 2.7 degrees by 2100. My last slide is just to make some commentary on extremes in the context of dangers for human ecological systems. And the IPCC Working Group 2 people will talk about what it means for Australia and Antarctic and so on later. But firstly, the IPCC projects. I say these are statements from the IPCC back in August last year. Precipitation and land water flows to become more variable over most land regions globally. Okay, that hits home a bit now, doesn't it, after the statement earlier. Decline in tropical cyclone frequency, but increased intensity. We can unpack like that later. Increased frequency and intensity of extremes. Again, heavy rainfall events, flooding, drought, heat waves, atmosphere and ocean, and extreme sea level events. Very much headline news. So just to give a bit of a feeling for what it means in terms of hot temperature events, here you can see back in 1850 to 1900, if we just think about 50-year period here, and we think about the hottest temperature or the hottest day in that 50-year period. So that happens once. So that's a 1 in 50-year event, okay? Under present conditions of 1 degree or 1.1 degree, let's say, that now likely occurs in a 50-year period close to 5 times, or about a 1 in 10-year event. And then as we go forward through these scenarios to 1.5 and 2 degrees, 1.5 is likely about 8 to 9 times, or about every 6 years. At 2 degrees, about every 3 to 4 years. And if we get to 4 degrees, we don't really want to go there. I mean, that's just goes beggars belief. Nearly every year at 4 degrees. Okay, I'm going to leave you with that, and I will move on to the next speaker. Thank you.
Thanks, Neil. That takes us up to where we are with this current report being released. As I welcome Nathan Bindoff to the stage, I might just ask the panellists, do you mind just returning to your seats? I think we get a better view if we're sitting back there, and we know the drill now, so Phil, you'll be the next one up when we change after this. So I think take it where we can get a better look. Thank you, Nathan.
Thank you very much, Alastair. Thank you to the organisers for being able to talk a little bit about Dr. Rebecca Harris. And Rufus has already mentioned Rebecca Harris. Beck died on the 24th of December last year. She was a contributor to the Climate Futures Group, and I'll talk very briefly about that in a moment. And also, as is very fitting for this tribute, she was a contributor to the IPCC Working Group 2 report released just yesterday. I took the punt in 2011, 2012 and appointed Beck to be a research associate, and then actually at some point later she became the director of the Climate Futures Group. She and the Climate Futures Group developed up these fantastic reports, technical reports that gave us information about the impacts and consequences of climate change for not just Tasmania alone, but actually also for the whole of the nation. It culminated in the most wonderful report around the future of wine across all of the wine regions of Australia. Beck didn't just, with the Climate Futures Group, produce fantastic reports, she communicated them to the wider community. But she was also a teacher and a researcher. And this slide here, which you'll see sort of variations in the following talks, is an example of the work that Beck did as a collaboration with a group of researchers across Australia. It was published in Nature, and you don't have to take in the slide. The important point was that you might wonder why it is that ecosystems collapse. And that paper gave some beautiful examples of how the inexorable changes in the climate system mixed with weather, mixed with other changes, with things that cross critical thresholds, whether it be kelp in the top right part, or whether it be trees, the mountain ash, delegatensis in the southeastern highlands. With the press of climate change, these ecosystems can collapse. And that paper brings that to the point. We should not be surprised by collapses in our ecosystems as a consequence of slowly changing climate change. Beck contributed to the IPCC Working Group 2. She contributed to the Chapter 2 around terrestrial and freshwater ecosystems and their services. She delivered also a cross-chapter paper with others on deserts, semi-arid areas and desertification. Gretta Pecl, in communication with the IPCC Working Group 2 co-chair, Deborah Roberts. There are 2 co-chairs. Deborah is located in South Africa, and these are the words that she has about Beck.
To everyone gathered at this event in Hobart today, my very warmest greetings from Africa. I just wanted to say how sad and shocked we all were in Working Group 2 to hear of Beck's sudden passing. What a really tragic loss for the scientific community and the global community at large. In many ways, she was the epitome of what the sixth assessment cycle of the Intergovernmental Panel on Climate Change is all about. She was someone who could bridge the worlds of the natural and built environments and could contribute deep insights to both. She'll be sorely missed by us all, there is no doubt, and our very deepest condolences to her families and friends. Thank you very much.
And Bec had just a career of 1 decade in climate impacts at this university. She'd had a life beforehand, in fact. There were 66 publications. And in the period afterwards, beginning of this year, I had the Southern Tasmanian Council Association and the Northern equivalent in Tasmania write to me and reflect on the contributions Bec had made in communicating to the Tasmanian community and more broadly through the Wine Australia project. Bec will be sorely missed by the Tasmanian climate community. Thank you very much.
Thanks for that, Nathan. We're going to move to first of the chapters here in Working Group 2. This is on the oceans. And I thought I'd start because you're going to receive a welter of information this evening with 2 of the key take-home messages from this chapter and also from the cross-chapter box on responses to extremes that Bec Harris led. And the first of these is that, following on from what Neil said, the number of extreme events, such as marine heat waves, is increasing, and that's going to pose an unprecedented threat to marine life, particularly because of this 1-2 punch of the very abruptness of these events and also their, in many cases, extreme magnitude. The second example then moves beyond what we call a single stressor. So in this case here, a single stressor is a marine heat wave. In this case here, we're seeing that we're getting these cumulative pressures exerted on marine life by these multiple stressors. And in some cases, these multiple stressors, warming, acidification, low oxygen, low nutrients, can actually manifest themselves as what we're now terming compound extremes. So it's a marine heat wave overprinted with additional threats and the corresponding cumulative pressure. I'll just show you briefly, this is the infographic. I'm just able to touch on a couple of areas this evening. So these stressors or extremes, acidification, warming, deoxygenation, and then the other focus we have on the right-hand side here, then trying to get a head around what we know and what we understand about the strategies that marine life has to acclimate, to evolve, and where in some cases we actually see mortality and extinction. Why did that happen? This is a slide then that Bec and I put together, and you can see it chimes on the one that Nathan showed, but essentially a couple of take-homes here. We see, as Neil pointed out, as these extremes become more and more frequent, the recovery time for marine life becomes shorter and shorter, and subsequently we start to move up into this red zone where we have enough recovery time, then we can just about survive the extreme after extreme, and then we move into a period then where we have mortality events and extinctions. So then this picks up on, again, the slide that Neil showed you. This is a typical slide that we see. This is from the summary from Policymakers Working Group 1 from last year. And what we see here in the case of warming, we have a range of emission scenarios. That gives us a series of trajectories in terms of warming. And when we look at that, we think, well, not really going up by that much. It's a fraction of a degree. It's a tenth of a degree every year. It's a fraction of a degree maybe every decade. And we've got up to 2100. That's enough time. The next generation, some of the young people who are here this evening, that they can pick up and do some heavy lifting. But this is just the mean. This is just a change in the mean that we're seeing here. So let me overlay an extreme on this. This is the blob. This is a major heat wave. We've had one since called Blob 2.0. Heat wave in the Pacific with a 6-degree increase relative to the previous decade. So that's not 2100. That's the here and now. That's what we're actually seeing at the moment. And that's the very frightening thing about these extreme events. We see these here. The blob had widespread ramifications from Alaska right down to the Californian seaboard. Mammal strandings, mass mortality, closed fisheries. If you like, an ecological chain reaction to this extreme event. And that really, I think, is the game changer, having been involved in AR5 for the oceans, that I see in this report now, and then also in the SROC. So what I'd like to do then is explore the responses to this here using this very simple conceptual framework, which is a thermal tolerance curve. I say simple because we all have one of these. If we look over on the left, there's the human shiver function to try and pull it together at the cold extreme. Equally, at the far end of our tolerance range for this curve here, depending on who we are, we're either sweating, perspiring, or merely glowing. But again, we're using that as a strategy to cope with an extreme environment. So what we'll do here is we'll actually overlay then this mean change that we're seeing out to 2100 and then some extremes. In this case here, we're seeing this nth of a degree or fraction of a degree over a decade, over a number of years. It's certainly pushing us out beyond our comfort zone, but hey, you know, we can adjust. We've got years or possibly even a decade to get adjusted, to get acclimated to this. If we look at the extreme event, then we're looking at something that happens on a time scale of weeks to months. With the blob, for example, it's more difficult. It was more of a mosaic to piece together exactly how long it took, but some recent work out of BOM here in CSIRO points to very short timescales of effect and recovery times on a time scale of days. This pushes us out over this thermal cliff face. And so how are we going to respond to something in the here and now that's doing that? Well, as humans, we're lucky. We've got a whole bunch of different strategies to combat extremes. On the left here, you've probably seen a few of these in January down in Salamanca. There are people from Queenstown, people from Queensland who are coming south for the first time and have got their puffer jackets on. As we move to the other extremes, we're some Tasmanians then up at the top end with cold drinks, a fan, and hugging the AC because they're trying to adjust. Usually you find you've just adjusted to the temperature by the time you come back to Tassie and have to put on a puffer jacket. So it's also the same then when it comes to marine life. We have a range of strategies. On short timescales, we can have acclimation. We can switch on mechanisms which reduce things like heat shock proteins that can help offset some of these rapid changes. On longer timescales of usually years or longer, we can adapt, we can move, or we can die. And what I'd like to really leave you with tonight is this sort of 1-2 punch of this very abrupt but very large signal in some of these extremes actually knocks over the first two. In many cases, the combination of abruptness and the magnitude means you can't acclimate. Your AC spec won't let you keep running quickly enough to actually then cope with this very abrupt shift. Adaptation, which is longer term, is also not possible. And so that leaves essentially two options. We move or we die. And to put things back then into the Australian context, this image here, almost iconic from the Great Barrier Reef, we see that not all of our marine life is actually able to have both options. Some can move, some cannot, and that's why we end up with these more regularly occurring sort of bleaching events up on the reef. Just to come back then to the second point I made, in the top left, you've got one of these thermal performance curves, but we're starting to see then these multiple stressors actually acting in concert. So here, warming and acidification, a figure from chapter 3. On oceans, here we have another curve then for the effect of pH and ocean acidification. We end up with this very complex response landscape, and that was one of the challenges in the report, was to try and better understand what options there are for marine life, what challenges and what benefits we can have. And I'll leave you then with, these are two of the statements from the ocean chapter. This is using the calibrated uncertainty language that Gretta mentioned. You can see we've got very high confidence, and very high confidence of what's going to be happening in the future, again, based on a huge amount of evidence. Thank you.
Thank you very much, Philip Boyd, for also handling one of the toughest transitions for a speaker, I suggest. The next speaker is a pairwise combination of Jess Melbourne-Thomas and Andrew Constable. Come on down.
Thanks, Alastair, and I also add my thanks to Philip for speaking after Nathan and the tribute, which was very moving. So good evening, everyone, and thank you for the opportunity to speak tonight on the sensitivity of Antarctic ecosystems and consequent impacts on global systems. I wasn't an author on this recent sixth assessment report. I did work as a lead author on one of the special reports that Gretta mentioned. I worked on the polar regions chapter of the special report on the oceans and cryosphere in a changing climate, which came out in 2009. And so I'd like to start then by acknowledging the authors of one of the cross-chapter papers that Gretta mentioned, number 6 on polar regions, and this talk draws largely from that chapter. The overall leads of the chapter are Andrew Constable and Shirley Harper, and there's also another 5 lead authors who've contributed. It's a very accessible paper. I'd encourage you to take a look if you're interested. The language is very accessible, it's very informative, and the key messages are very clearly articulated, and they're also very compelling, which has made my job in attempting to synthesise them a little bit easier. And so this then is a synthesis of 5 key messages from that chapter for Antarctic and Southern Ocean systems. So firstly, Antarctica is at the front line of climate change impacts. That's something that we also reported in 2019. There's a clear message that the Southern Ocean will be profoundly different by 2050 under all of the warming scenarios that you've heard about already this evening. Polar species literally have nowhere to go as oceans warm and sea ice melts, which makes them somewhat unique in terms of ocean systems. And there are limits to adaptation in polar regions, which are quite high, and maladaptation is probable, reported as probable in the cross-chapter paper. And then finally, I'd like to emphasise that what happens in the Southern Ocean actually affects everybody because of the global connections that I'll touch on. So this recent report clearly confirms what's already been established in previous reports, that Antarctica and the Southern Ocean are regions of large and rapid change. That's true both now and into the future based on our projections, and I've just pulled out this quote which I think captures that well. Polar regions are experiencing impacts from climate change at magnitudes and rates that are among the highest in the world, and as I indicated, that means they'll be profoundly different in the near-term future, so by 2050. And this is just a snapshot from a recent media article last week reporting that Antarctic sea ice this year has fallen to the lowest level since measurements began in 1979. We've heard quite a lot about extreme events so far this evening. The authors of this study haven't yet established climate change as the driver of this low, but I think it certainly emphasised that there is rapid change occurring right at this moment in Antarctica. So another key point from the list I showed you earlier is that Antarctic species have nowhere to go, and so contractions of polar climate zones, as we see warming, lead to distribution shifts and also changes in food webs and ecosystem function, induce declines in many species, and then that has impacts on subsistence harvests in the Arctic and on commercial fisheries at both poles, and threatens global dependence on polar regions for substantial marine food production. So while rising temperatures are a key part of this habitat contraction, as Philip has clearly highlighted, there are multiple drivers which can interact with each other to affect species in different ways. And so for Antarctica and the Southern Ocean, this includes changes in wind and circulation patterns, sea ice loss, but also retreats of glaciers and ice shelf collapse, nutrient and freshwater input, ocean acidification, changes to primary production, and also other human stresses like pollutants, fishing and tourism. So just a brief summary then, given the time, of what's actually happening and what's projected to happen in the future for Southern Ocean ecosystems and food webs. So far we've observed range contractions for this key species, Antarctic krill, where their highest densities occur in the Atlantic sector. And we expect that in the future, the distribution of krill and other cold adapted species will shift. And those that can't shift might either need to travel further to access food, or they might run out of habitat altogether. Benthic systems are also changing because of temperature and also massive changes in light conditions that result when we see these disintegration events of ice shelves that are already occurring at different locations around the continent. Calcifying organisms, that includes many benthic species, but also krill and other plankton like pteropods, are sensitive to ocean acidification, and we're learning more about how these sensitivities depend on life stages and might also interact with other factors such as light and nutrients. And then finally, all of these changes have implications for the way that food webs function and the way that energy flows from phytoplankton through zooplankton and other trophic levels to higher predators like penguins and seals. I just wanted to briefly note that it is really important to recognise that for the Southern Ocean as well as in the Arctic, the nature of climate-driven habitat and ecosystem change is spatially variable, and this is true for pretty much all parts of the food web. And I guess it's not surprising actually, given the vast spatial scales and the dynamic environments that we're talking about, but it does present some challenges in terms of responding to impacts. And so the report and the cross-chapter paper highlights that for polar regions, important factors and tools that influence our ability to respond to climate-driven ecosystem change include things like ecosystem-based management, as well as access to forecasts and projections, and climate-informed advice that can promote adaptation and climate resilience, particularly in fisheries. And also importantly, that coupling adaptation measures with global carbon mitigation strategies really substantially decreases climate change risks to polar fisheries. And there are a range of adaptation options for Antarctic ecosystems, as well as ecosystem services and coastal infrastructure in Antarctica. But there are also, as I highlighted, some important limits to adaptation which will occur in the future and related to the rate of warming and also the cascading changes that are occurring. So effective adaptation requires effective mechanisms to implement adaptation actions, and again the report highlights that while climate action plans exist for terrestrial and nearshore Antarctica, governance for managing climate impacts is fairly poorly developed actually for marine ecosystems, although strategies have been proposed. So just to conclude then, emphasising, as I said at the start, what happens in the Southern Ocean actually does affect everyone. There's no resident population in Antarctica, obviously, which means that in fact the global population is the Antarctic population, and we all have an interest in maintaining a healthy Southern Ocean ecosystem. And so I think that's particularly true for a gateway, an Antarctic gateway like Tasmania, and continued investment in observations and dynamic ecosystem modelling at circumpolar scales will help us understand what alternative futures might look like for the Southern Ocean and inform how we might achieve those futures. And then alongside the biophysical values of the Southern Ocean ecosystem, I'd also argue that we do need to acknowledge the cultural connections that we have with it, and these are connections that I think future generations have an equal right to enjoy. So I think I've got time then just to finish with a couple of beautiful cartoons that were created by Eve Brennan and that Andrew and I presented as part of a side event at last year's COP26, the Conference of the Parties event in Glasgow. And the comics tell a story about different futures that relate to the targets that you heard about earlier from the Paris Agreement. So the Antarctic and Southern Ocean is home to an ecosystem that holds global significance as a heat and carbon sink. It's a place that captures the imagination of people around the world, and it also supports fisheries and tourism. It's a key part of global ocean circulation, where carbon and nutrients sink to the bottom of the ocean and travel around the world. Phytoplankton and krill form the foundation of a marine world where species travel from the equator every year, while others depend on ice environments for food and breeding. Where corals, sponges and bottom-dwelling species have evolved in freezing waters and need those waters to remain cold in order to survive. Right now, the Southern Ocean needs climate change mitigation to continue the ecosystem processes that everyone needs. And so we asked the COP26 audience, and I'd invite you again now to consider two possible futures for the Southern Ocean ecosystem. One where by limiting warming to 1.5 degrees, we can preserve and maintain the things that we care about and depend upon from the Southern Ocean. And another where beyond this level, our current scientific understanding is that ecosystem services will be degraded and that we will lose key elements of the system. And at 2 degrees of warming, the risks are very high and it's unclear whether recovery would indeed ever be possible. So I might leave it there and pass over to the next speaker. Thank you very much. Thank you very much, Jess. I really love those cartoons, particularly the 1.5 one. So I'm going to be presenting tonight some of the key findings for Australia. So the findings that are relevant from the report on impacts and adaptation and vulnerability for Australia. So these are some of the findings from that chapter, from chapter 11. And so I wanted to acknowledge the co-authors that contributed to this chapter. And in addition to these people, there's another 41 contributing co-authors. So authors that we tap on the shoulder and ask for contributions for particular issues. And there's too many names to whack on that slide, but I wanted to make sure that we acknowledge them there. Our chapter was very clear on the finding that climate trends and extreme events have combined with exposure and vulnerabilities to cause major impacts for many natural systems, some that are experiencing or at risk of irreversible change in Australia. Just about actually every region in the IPCC assessment report had this as a major finding or something very, very similar to it. And the same with this statement here. Extreme events such as heat waves, droughts, floods, storms, fires have caused deaths and injuries and affected many households, communities and businesses via impacts on ecosystems, infrastructure, essential services, food production, the national economy, valued places and employment. Every single chapter in the report dealing with different regions had statements along these lines with very high confidence. To get into some specifics, for Australia, the changing flood risk. So extremely high rainfall will become more intense, and unfortunately we're living through an example in the northern part of our country of that again. So the projections are that flood risk will increase in cities, urban areas and small catchments, and that the flood response in rural areas will depend on changes to high extreme rainfall and catchment conditions. Unfortunately, adaptation to changing flood risks at the moment is mostly reactive and incremental in response to floods. So we need to get a little bit more proactive about planning and implementing those plans for how we deal with some of these extreme events around our country. Floods are one of the most expensive extreme events that we experience, and on average it costs Australia $8.8 billion a year, in addition, obviously, to the very important human toll that floods unfortunately have as well. Escalating impacts and risks of wildfire was also another key risk for Australia, with that frequency and severity of dangerous fire weather conditions increasing and projected very clearly to continue to increase over time as well. One thing that was highlighted in this report is that it's no longer a case of single events or simple single events, as some other speakers have mentioned. These events are now so unprecedented, so large, and coming one on top of the other or at the same time in different parts of the country, that we're now having situations where there's compounding aggregate impacts of fires and floods and droughts that are really starting to overwhelm some of our systems. I've got another slide that highlights just some of the impacts of that 2019-2020 extreme fire events that we had, and we were actually in an IPCC meeting working on these reports in Faro, I think it was. Yes, I forget which country it was, in Portugal, writing the IPCC chapter for Australia while these impacts were ravaging our country. So that felt a bit surreal. But just that one fire season, 33 deaths and over 3,000 homes lost, $2.3 billion in insured losses, $3.6 billion of losses in tourism, hospitality, agriculture and forestry. I won't read that whole list, and there's probably another couple of slides of impacts that we could have listed just for this one event. 114 listed threatened species lost at least 50% of their habitat. We lost at least 3 billion vertebrate animals without considering all the other components of the ecosystem. Smoke carried over 4,000 kilometres to New Zealand, increasing their snow and glacier melt. So, one extreme event, and that had ripples and ramifications in many, many different ways through different sectors of our community. Another finding of the Australasian chapter, again with very high confidence, was those observed impacts for coral reefs. And the official assessment was that significant loss and degradation of coral reefs and associated biodiversity and ecosystem service values due to ocean warming and marine heat waves. The Great Barrier Reef experienced 3 heat waves and 3 more or less back-to-back bleaching events in just 5 years, so 2016, 2017, 2020. Each one of those years was a marine heat wave where there's accumulated thermal stress for the coral systems. If that thermal stress stays there, the coral is bleached, and if the thermal stress continues, the coral then dies. So bleaching does not necessarily mean the coral dies. It means it was severely stressed and may take some time to recover. But if that thermal stress stays there for long enough, the coral then dies. So we've had 3 of those bleaching events with subsequent death of corals in those 3 years. The important point to remember is that recovery of coral reefs following these disturbing events is very, very slow. So it takes a minimum of 10 years for the very fastest corals to grow and to start to recover. And the rate of coral growth is very, very variable. Some corals grow extremely slowly, others grow very fast, but it's 10 years minimum for those very fastest corals. In another unfortunate message, dead coral does not make babies. And in 2018, a very large study documented that the recruitment of coral, or the production of baby coral to try and replenish the coral reefs, was reduced to 11% of the long-term average. So less than 11% of the normal production of the new generations to try and replenish the reef systems. It's also not a great news story for our temperate reefs. So our tropical systems are absolutely under threat from climate change, but so are our our temperate reef systems here in Tasmania and in other parts of southern Australia. So we've had loss of kelp forests in southern Australia due to ocean warming with high confidence. That's due to the underlying warming of the ocean. It's also due to an extension of the East Australian current, that current that brought Nemo's dad cruising down the coast in the movie there. The East Australian current is pushing further down our coast, in large part because of warming over the Pacific Ocean. It literally forces that current system further down our coast. The East Australian current is a nutrient-poor system. So our poor kelp gets warming waters, nutrient-poor waters, and then another climate trend that's happening is that as our waters warm up, new species can come in. We're getting tropical fish and tropical urchins and other warmer water species that are eating the kelp as well to a higher rate than what they're used to. So it has this multiple impacts that's led to less than 10% of the giant kelp in Tasmania now remaining, and giant kelp is actually listed as an endangered ecological community now. It's not just Tasmania or the southeast of Australia. Western Australia and other parts of our coast are also impacted by massive losses of kelp systems, including a 100-kilometre range contraction of kelp forests in WA. And over the entire continent, we've lost kelp species of around 140 hectares, so 140,000 hectares of kelp systems have been lost. And in fact, if you look across the Australian coastline, extreme climatic events from 2011 to 2017 has led to the abrupt and extensive mortality of key habitat-forming organisms around 45% of our coastline. And that's an assessment of high confidence. So corals, kelps, seagrasses, mangroves, all things that other species need to live and as habitat and food and shelter and those sorts of things, around 45% of the coastline has been severely impacted by climate. It's not just these habitat-forming species, but the impact of climate change in marine systems is much more pervasive than that. We now have new occurrences or increased prevalence of diseases and toxins and viruses that are evident. And at least 198 species from 9 different taxonomic groups, so lots of different types of critters that have shifted their distribution since 2003 around our country. That is because as our waters warm, plants and animals in the northern hemisphere are moving north and plants and animals in the southern hemisphere are moving south. So it's a climate-driven change in distribution as plants and animals are trying to keep up with their preferred environmental temperatures. So it's literally a redistribution of life on Earth, and one of the assessments from the report as a whole is that around 50% of the species studied are now documented to be undertaking climate-driven changes in distribution. Just to finish up on some projected risks for marine systems, even temporarily exceeding that 1.5 degree of warming is likely to result in severe and potentially irreversible impacts, particularly for the Great Barrier Reef, for example. Globally, the estimates of the conditions, so those thermal conditions that would lead to bleaching, projected to be twice each decade from 2035. Doesn't take a rocket scientist to figure out that's not going to work with a minimum 10-year recovery time. That's under a high emissions scenario, so pretty much the trajectory that we're on, but annually after 2051 under a low emissions scenario. So some challenges for the reef there. And if bleaching persists, in addition, and I'm hoping it's obvious that this is in addition to the extreme ecological values that would be lost and the cultural values that would be lost, if bleaching persists, an estimated 10,000 jobs and $1 billion in revenue would be lost each year just from declines in tourism alone. Unfortunately, limiting warming to 1.5 degrees is insufficient to prevent more frequent mass bleaching events, but it could reduce the occurrence of warming events by about 25%. We do need to reduce other anthropogenic, so other pollution and other stresses on the Great Barrier Reef to help improve its natural adaptive capacity. There are some adaptation efforts that are underway, coral restoration, for example. This might be effective in slowing impacts in small patches of the reef or reduce short-term socio-economic ramifications, but it's not going to prevent widespread bleaching. Only reducing emissions will do that. And in terms of kelp adaptation options, we can minimise other stresses, that we can do local restoration. There are some fantastic projects here at the University of Tasmania transplanting heat-tolerant critters of the kelp. That's something that's showing a lot of promise. However, even those kinds of adaptation options are not a permanent fix and are subject to ongoing warming and ongoing challenges. So I'll finish there, but thank you very much.
Good evening, everybody. It's a great privilege to be part of this presentation. And it's been a great privilege over the course of the whole experience to be part of 270 scientists who are extremely motivated to find solutions for our world. I was part of the last 2 weeks of the approvals process, and I can assure you that despite the doom and gloom that we hear about, there is a very positive sense that we can do something within the next decade. But it needs to be done in the next decade. So what I'm going to talk to you this evening about in a fairly short presentation is what approaches we might take to be successful. What do we need to do to achieve a highly desirable world? One where we can assure that everybody has an opportunity to well-being, that there is low poverty, that we have ecosystem health, we have equity and justice, and we have low global warming levels that gives us low risk. That is our goal. So what can we do about that? First of all, as we've heard already, and if you read through the report, you will see that climate change is affecting you. You can't escape it. You have to think about how is it affecting you and what can you do about facilitating change. We hear a lot about the impacts of droughts, floods, changes in crop production. We hear about how fires, even in Hobart, impinge on our city life. We also hear about how cities are heat sinks, causing thermal stress for its people. What we don't often hear about, and one of the great successes of this report, has been understanding better the cascading effects that climate change has through ecosystems that we've heard about, but also through communities, through the way that people live. For example, reduced crop production or fire events, flooding events, they all impact the supply of the things that we value. So we'll see less of that. They also impact the fact that public money, government expenditure, will go to help people recover from disasters. That's money that can't be spent elsewhere. We also hear about how the private sector that tries to fund a number of different activities within our world, they also divert funds. But what also underpins it, if you look at the special box on finance, you look at some of the text that's around insurance pathways, the costs for us all in our living increases. And one of the things about the increases in the costs is that that affects everybody, and particularly that affects vulnerable people and vulnerable communities. It affects them more because they have less money available to expend on things like housing, health, food, water, safety, and the list goes on. And these topics are thoroughly developed in this report, unlike previous reports. So the picture is very clear how climate change is affecting us. The other point that the report makes clear, and it's good the way the report develops the conclusions that Neil presented before from Working Group 1. It's not the scenarios that we hear about, and Philip pointed that out, that a little degree here and a little degree there, what does that matter? Well, when you look at that on a graph, it looks like it doesn't matter, but in fact it does. Net emissions matter, not net zero carbon in a particular year, but net zero, the net emissions accumulated over time. And what that translates to, and Neil showed this very well before, what that translates to is what the global warming level is. How much above pre-industrial times has the world warmed? And Philip pointed out that it's not the same average everywhere. Some places are getting much, much hotter than they have been before. Some places that were cold are getting warm. And the extreme events will vary around the planet. And so we have to bear in mind what the global warming is. What I show you here is on the y-axis is the global surface temperature change. So that's the global warming level. It's the average surface temperature of the whole planet. These are called burning embers, and I show you two for Australia. One is the loss and degradation of coral reefs in Australia, and we've already heard about that from Gretta. And the second one is the cascading impacts on cities and settlements, and this is in Australia and New Zealand. But what the colours show you is when will that get to severe risk. Severe risk is purple. Moderate to high risk is the yellow, and you can see going from yellow to purple, when does it reach purple? And you can see that for coral reefs, it reaches purple before it gets past the existing temperature that we're living in. And that's what Gretta was talking about. But for our cities, it reaches purple around about 2 degrees. One of the overwhelming things about this report is that it's very clear that for all regions, climate change is dangerous for people and ecosystems and likely to be dangerous for many sub-regions and locations by 2 degrees. So 1.5 degrees is not just a target temperature in the Paris Agreement, it's actually very important for planetary health and our well-being. Another point that was important in all chapters, but particularly if you read the last 3 chapters, there's one on risks and adaptation, there's one on decision-making, which is what I was involved in, and then there's one on climate resilient development. And I was engaged with the authors of that chapter in preparing for the summary for policymakers. And it's a clear conclusion that we need to anticipate what's going to happen, and we need to take action before those risks eventuate. That's really important to us. We can't wait for the evidence, the actual tangible experience, like a flood in southeast Queensland and northern New South Wales. We can't wait for those experiences to mount up before we take action to prepare and reduce those risks. And I note here that we need to find low regrets pathways. What are those pathways that would do us well, whether or not the future holds what we think is in store? Good ecosystems, functioning cities and communities, a green environment. These are all important to us, no matter what the global warming level is. So it makes sense to actually move down those pathways before we wait for the water to be around our knees, like is going to happen in some communities very soon. I also point out that it takes time. Working Group 1 has told us that we need to act in the next decade. And what they mean by that is we need to take suitable mitigation measures, and we need to prepare ourselves for what's in store within the next decade, at least to get prepared and to make moves in that direction. So in the next 10 years, we need to take account of the processes that we might need to undertake as a nation. We need to plan and prepare as states and cities and communities. And the report helps guide us in what that might mean. But I put these reports up here because these were written in the 1990s and they're still in the process of being discussed in order to understand how to implement them. So that gives you a sense of how long some of the administrative environments take in order to be prepared. We can't afford to take that long. We need to set up planning processes that are quick, that identify very quickly what the pathways will be to give us the best chance of surviving in the future. We also need to take action which is integrated. 10 years is not much time to get ourselves together. We need to be able to learn from what we've done already, and we need to be able to learn as we go, because we will make mistakes. So we need to be able to set up programs that give us the data, that give us the experience, and help translate that experience into better options for the future. I put up this map of Australia of catchments, and the solid black lines show you the larger catchment areas that are managed for their water. And then you can see the river systems within. What's important about those catchments is that, as we all know with the Murray-Darling Basin, they overlap states. They overlap many jurisdictions. There needs to be discussions between those jurisdictions. For some regions of the world, those jurisdictions are across countries, so they need to have an international dimension to their discussions. But that's what we mean by integration. We need to be able to make sure that we're not just working individually, but we're working together. So, for example, if Queensland made sure that they were safe in their water security, they could prejudice what's going on in New South Wales, Victoria and South Australia. And we've heard lots about those discussions already. But you can apply this same logic to the development of cities, the development of trading partnerships and so on. So we need to think about how can we best integrate from our households right through to nations to internationally. One of the most important findings in our report was that we need to respect different knowledge systems. We need to engage with all peoples, all communities. We need to do that because there will be an impact if we don't. The cascading effects that we talk about is how local communities and households will become disenfranchised if they're not given enough attention to how they can adapt, how they can respond to what's going on. And I show you here the most compelling reading in the report is about small islands and coastal communities that will suffer from sea level rise and are already starting to experience the problems that they face when cyclones and the like happen. So we need to engage with everybody so as we can ensure there is equity for all, that there is justice, because the vulnerable communities are going to be the ones that are going to be hit hard. Ecosystems are unable to defend themselves, but we know that good ecosystems are important for our own survival. So these points are key to our success. So climate resilient development is an extension of the Sustainable Development Goals. You will have seen these on the right-hand side of the panel if you've browsed those. All of these goals are at risk. We've heard how there is compounding events that happen, that climate change can compound existing inequities, existing injustices and existing problems. So we need to think about how we interact with one another and how we solve problems within communities, within socio-cultural environments, within our political environments, the ecological environments. We need to consider how all knowledge systems can help us, how might technologies help us. And we need to think about how economies and the financial systems might hinder or enhance our development. We have the opportunity of choosing between the green pathway, which is towards a sustainable future and equity and justice for all, or we can choose the red pathway, which is the pathway that we're currently on. We need to find a way that will move us in a positive direction. So that may sound very gloomy, but as I started, I was really excited about being involved with so many passionate scientists, volunteers that work with the IPCC. They know that there are solutions out there, but they've also recognised that the past and current development trends have not advanced global climate resilient development. Very high confidence, agreed to by all governments in the IPCC. And of great significance, this is the first time that Working Group 2 has been able to say that climate change is a threat to human well-being and planetary health. Any further delay in concerted global action will miss a brief, rapidly closing window of opportunity to secure a livable and sustainable future for all. So we can do it. We have to make the choices. We have to act within whatever scope we have available to us to act. Thank you very much.
Phew. I'm going to ask the speakers to please come to the panel stage at the front here. Anyone needs a stretch, feel free to just stand up. My leg nearly was not going to let me get down easily. If you need a stretch, just take a minute to stand up for a sec. Speakers, ready? I've got 20 minutes of question time. I'm going to cut you off if you give me long answers. All righty. We've got some of the questions that are coming through the online tool. Audience members in the flesh, I'd ask you to please use the same system. I'm juggling it here on my phone with glasses somewhere. And can you just leave that one for a sec? Give me a bit of a hey if people have been able to do this roughly. A couple of hands to show me some people got it. In fact, there's a great solution. Take a photo of it if you're not keeping up with the tapping in part of it. Beauty. Ceci, what are you going to show me? Okay, no, let's give them a bit longer and then we'll put it up. Beauty. All set. 20 minutes of rapid fire. You all set, team over there? Neil. Yep. New South Wales, Queensland, undergoing massive flooding. Does the term 1 in 1,000 year flood, 1 in 100 year flood have any value to us anymore? Go.
Phew, that's a good question. Don't know. I would say that one thing that's very clear from the floods that are happening in Queensland right now is that will be an expectation far more often under climate change. I think that's very clear. 1 in 1,000 years? No.
No meaning. Thank you very much.
No, not 1 in 1,000 years. Nope. No way.
Here we go again. Greta. Governments are seen around the world as delaying action on climate change. In the IPCC process, can governments spin the answer?
Can they be?
Can a government spin the answer that the IPCC produces?
Not really, and that's probably a question for Andrew, who was in the summary for policymakers meeting over the last couple of weeks, and lead authors like Andrew and like the coordinating lead authors for the Australian chapter are in those meetings to make sure that the meaning of all our work doesn't get watered down. So there's a 3,500-page report, and we try and whittle that down to a 40-page or ish summary for policymakers. And in that summary for policymakers, that's the bit that has to get approved by every one of those government nations, and they go through it line by line by line. And Andrew can probably tell you more about that process, but my understanding is that the lead authors are there to make sure that, although the language might change a little, that the integrity of our work is not misrepresented.
I'm happy with that answer, and so is the audience. Thank you. Jess, you suggested we should read the IPCC report, but it's hundreds and hundreds of pages. How are we realistically going to read it, and what's your suggestions for navigating it?
I think the way that it is structured, and I think the fact that Gretta introduced us to, all of the complexities of IPCC was actually really helpful, because the summary for policymakers is actually intended to be fairly generally accessible, right? So, you start at the top, and then if there's bits you're interested in particularly, you drill down. So it's just about knowing that's how you go about it, and maybe we have a better job to do of explaining to people, that's how you would approach it. That said, I do think we have more of a job to do on the kind of translation end of things, in taking the key messages that are in the report to different audiences in a way that's most engaging and meaningful for them. So that's a slightly different question. But I would maintain that, the report's there for people to read.
Should we print it out?
Don't print it out.
Do not print it out. The carbon footprint of all of you printing it out would be terrible. Read it online, please.
Don't do
that. Philip, you talked a lot about extreme events, and those are the things that are going to bring an impact to us very rapidly. What prospect have we got of forecasting extreme events like heat waves or floods?
Well, there's some very nice work. I won't embarrass you, Alistair, but it's a very nice work being done here in Australia by both BOM and by CSIRO in Hobart, looking at statistical analysis, looking at trigger points. There are other analogues out there, things like, believe it or not, the onset of an epileptic fit. Also, that there are some commonalities across a whole range of different extreme events. So people are looking for some of these sort of trigger points. And obviously, because in many cases these are actually globally driven events, it's difficult then to do anything probably in the meantime other than maybe come up with an early warning system. But you're to be congratulated on the big role you're playing in that, along with many others.
Thank you. Yes, we can forecast them. Look on your internet as well. Thank you, Philip. Andrew, you're pretty bullish on the idea that we've got a 10-year period and we can respond. What are some of the things we can do with our money, perhaps, to make the climate change action come more quickly? Does the report talk about the superannuation decisions we make or the investment in coal mines that we make?
In short, no. And there is a separation between what needs to be done for mitigation from what needs to be done for adaptation. This report deals with adaptation. The report that is to be approved in 3 weeks' time, the approvals process begins, and that will deal with what is the best pathways for mitigation. But there are a number of things that have been described in the report that are very important with respect to finance. It is recognised that the developed world has a special place in tackling climate change. The developing world, I should say, has a number of inherent difficulties that are captured in the discussions around sustainable development, and those difficulties will only be made much worse by climate change. In some chapters you can read about the emergence of disharmony and conflict, as well as the greater mobility of people in order to avoid the prospects as well as current climate change. And those things will get worse, and having finance appropriately looking about how to support the developing world is very important for us all. It's not something that we can ignore.
Thank you. I'm going to take buzzers for the next question, so get your hands on your buzzers, please. Can I see them on the table so I get it quite clearly who got there first? Thank you. Philip, come on. Put your hand on the table, because I feel like this is going to be you. What is the difference between what the world has to do in terms of being sustainable on a low emissions pathway compared to an intermediate emissions pathway? What are the things that describe those coloured lines that Neil showed there? Let me see a motion. Phil, excellent. I'm glad you put your hand on the desk there.
It's all a bit glacial up this way, but yes. It very much sort of looks at some of the transformations that have to be made in terms of economies. You know, we can't just simply go and turn off a coal-fired power station. Somewhere there has to be energy to come in to sort of fill that vacuum. There's also a whole socio-political chain of events that have to be satisfied for that to be palatable to electorates, and with the short, shall we say, electoral spin cycle of maybe 3 to 4 years to 5 years in some countries, that doesn't really give a lot of room for manoeuvre. And so it's sort of based on quite a bit of integrated assessment modelling, where they're looking right across at economies, at transitioning, and actually reducing emissions, develops some of those different scenarios.
So can I characterise them as they are instructions for how to get to different temperature levels in those storylines?
Yes.
Thank you.
First of all, you have the emissions and the CO2 burden and the greenhouse effect, and then the temperature. So sort of four knock-on effects.
Yep, beauty. Gretta, you advocate a lot for citizen science efforts to help with climate change, but I think, again, law and policy's got a real role to play. Tasmania's going to revise its Living Marine Resources Act, and there's a consultation period underway now. What will you recommend to the constructors of that act that they might do to prepare fisheries in Tasmania for a warmer world?
So I think there's a few key things that could be considered under that. Integrated management to a higher level, which was something that Andrew was highlighting in a different context, but integrated ecosystem management would be one thing that would help our systems a lot better. We actually did a study of most of the key fisheries in Australia, looking at their management plans, and only about a quarter of our fisheries across Australia have climate considerations in their management plans. So obviously with a review of the Act, that would be something to consider, some mechanism or process to ensure that climate change is actually factored into management plans, and the way that we manage those would be an advantage.
Judy, so thank you. I'm going to write it into the plan. What would I write into the plan? Can we move species around? Should we stock them in the ocean?
So you're asking about specific interventions?
Give me a specific intervention that you've seen in your research. What are people doing already?
So they are, well, the example that I mentioned around the thermally tolerant kelps, actually some of the interventions for restoring ecosystems, there's some fairly complex legislative and management requirements that need to be worked through for taking different types of species, different genotypes, and shifting them around. So obviously some planning and some consideration needs to go into doing that. What are we happy with? What are we not happy with? What risks do we want to take?
Beauty. So that consultation period's underway in Tasmania's case right now, and I imagine there are going to be other policies and pieces of legislation that are around the country. And I think when there are consultation periods, that is a chance to try and have a voice and make a submission to those activities. Jess, you talked about the threats to Antarctica. 1.5 degrees will be problematic for a lot of things that live on the ice. What do you think we should move penguins to Australia and keep them alive in cold cages for a couple of years until things cool down again? Or what might we do to help an ecosystem where there's nowhere to go?
Yeah, I think it's a really fundamentally challenging question for these iconic species, and one that's equally challenging for the Arctic. I guess one discussion to have is around some of those dramatic measures, and another consideration, I think importantly for us as a society, is if we overshoot and then the climate does eventually re-stabilise, would we ever see re-establishment of some of those species in extreme environments, and what does that mean kind of on the longer time horizon and for future generations? And so then, what actions might be available? What are the risks around thinking about longer term existence of some of these environments and iconic ecosystems?
Yep, beauty, thank you. And Neil, a lot of the graphs that you showed ended at the year 2100. Once we get to 2100, are we all sorted?
No, we're not all sorted, but that's just the projections that have been considered in this report, and we would hope that we're go on that SSP1 scenario so that we start going back down and we don't have to think about these things too much in future and that we've got it sorted. So let's hope for that.
We will not drag you down by showing
more than
what
hope.
happens to the
Let's
year,
sort it.
by the year 2300 if we're on that upper trajectory there.
That's another scenario.
That is. Again, Philip, I'm going to the question set here. This is again an adaptation discussion, and this report was about adaptation. If that is not enough, are there any geoengineering solutions currently available that would actually draw carbon dioxide out of the atmosphere?
Not at the moment.
Nope, not at the moment.
In summary, to keep it brief, if it would get social license at the minute, it will not scale, but it might be close to technical readiness. If it's something that will scale, which actually might then, because we do need the pull and push of emissions reduction and climate intervention, the 1.5 degree IPCC report made that very clear. If it's going to be something at scale that will make a difference, it's not within at least a decade, probably 2 decades, which is an important number that Andrew mentioned, of getting social license or being technically ready. That's it in a nutshell.
Thanks. You know, there are some very hard questions coming through, and I'm sorry, Andrew, that the next one's coming to you. You can roll your shoulders, get ready for this one. How do you see the dynamics between rich and poor countries playing out, and can we act in a way that is actually just for developing countries?
Yes, that is a hard question. COP27 is where this will play out. These reports have been...
and what year will COP27 meeting take place? We just had
this is this year. COP27 of the United Nations Framework Convention on Climate Change will occur later this year in Egypt. And it's a very important meeting because it more or less takes up where was left off from Scotland. And one of the points about this particular meeting is that there is a global stocktake to occur next year. And that global stocktake is about progress towards achieving the Paris Agreement. And one of the big points of discussion is how to estimate progress, but also what are the ramifications for that. And that's where the discussion between the developed and the developing world will take place. One of the points that came through in the discussions over the last 2 weeks was that there was, I thought, a very positive engagement across the nations about trying to articulate what the problem is and what the solutions need to be. And underpinning all of that, and you'll see this in the approved summary for policymakers, is that finance will play a very important role, and being able to establish flows of finance from the developed world to the developing world will be a very important outcome in the very short term. So how that will be achieved, we didn't discuss, but it's certainly there as an important issue to resolve.
All righty, I'm getting to the audience participation part of the night, and it's going to go in 2 ways here. Panellists, I'd like you to raise your hand if you think this IPCC report will make any more difference than the previous 5 in climate action. Members of the audience, I want you to get ready to raise your hands if you think this report and what you've heard tonight should stimulate governments and citizens any more than the previous 5 reports. Ready, panel, on the count of 3, your hand on your heart, will this report make the difference and get the world on a better trajectory? 1, 2, 3. Audience members, 1, 2, 3. Thank you very much. Online, there was an overwhelming feeling of positivity in the audience. May I wrap up? Andrew, don't get the mask back on because we're going to come very quickly back down the line like this, like this, like this. Andrew, how do you keep hopeful in working at times what must seem an overwhelming challenge that is in front of us? How do you stay positive? And as preparation down the line, it's going to be the same question all the way down.
I stay positive because while I listen to people that come from nations that in a national position have been intransigent, I'm very encouraged by the positive humanity that underpins their discussions. And I think that there is a general realisation that we do need to do something now. How that's done, I'm not sure, but that's my answer.
In a lab elsewhere in Australia, I can't tell you where, there is a small benchtop model that is drawing down its theoretical amount of CO2, but at the same time producing hydrogen. That's just one example of a whole global upswing of new companies and young people, and I was very heartened to see so many young people here tonight and not on Zoom. There's a whole group of people out there who I think are looking for technical solutions and quickly, and something that can be done in a way that's equitable and can be shared, not run by some monolithic corporation for profit is normally the case. So that gives me hope, Alistair.
I don't have anything poignant. I normally just go and have coffee with Gretta or Andrew. That gives me hope. Think about my kids.
All right, then, Jess, what do you say to your children at night to give them hope?
Train to be an astronaut, so that
No, don't be an astronaut. Terrible fossil fuel footprint in being an astronaut. And in fact, rocket scientists, we owe them no favours for how much carbon they put in the atmosphere. Thank you, Neil.
I stay positive because I think through my career, I guess I've been 30 years in this career, and I've seen from the beginning, when the first IPCC report was really coming out, and I got interested in understanding climate change, and there was tremendous, I guess, debate and opposition and scepticism around it, and I think through 30 years that has turned around dramatically. And while this particular, I put my hand up halfway, I guess to 2/3 of the way that this IPCC report would make a difference, I think we're actually starting to see change. And I think now, probably at the latter part of my career, I have tremendous hope, probably along the lines of what Andrew was talking about, that we're on a path where there's genuine recognition, understanding, embracing of where we're at, where we need to go. How to get there is going to be a hard road, but I remain optimistic that we will.
Well, I put my hand up, but I must admit that being optimistic is not really my natural state when it comes to climate change. However, just like our future and the path that we go down is a choice, I think optimism is a choice as well, and I think it's the only choice that we have, that we can make. Every action that we take, every bit of carbon we don't put in the atmosphere leads to a better outcome for everyone. And the one thing that does give me hope is the ferocious anger of young people. And I think that's something that really keeps a lot of climate scientists fired up. So if you're a young person and you go to those protests and you turn up and you demand a better future, then good on you, because that's certainly something that keeps a lot of us going.
Yeah, thanks very much. I think that it's overwhelmingly clear that a single report like this is now not the only reason that the world's taking action. And in a way, this IPCC report is proportionately less important than ever before, because the world is taking action and making decisions in so many other ways. So in that way, I think we're going to be in a very successful time, because the amount of evidence and the amount of weight and the motivation for change has actually never been higher. Thank you very much for attending tonight, both online and in the audience. This event was put together by the Centre for Marine Socioecology, a partnership between CSIRO and the University of Tasmania. It's an example of the type of events we try and do to bring things into everybody's living room, lounge room and conversation. Thank you very much for joining me tonight, and please thank the speakers for their efforts. Thank you. And ride those electric bikes home very carefully now, because it's dark outside.